everyone, today I'm gonna to present the chapter 4. It's called Fourier transforms analysis. So this is the first question. Given fx is equal to x over the interval minus pi, x and pi, and has period of 2 pi. So for f, we must sketch a graph of fx in the interval for negative 2 pi, x and 3 pi. So for the first, we need to draw a fx line like this. Then we're gonna copy the same function for the same fx from negative 3 pi to positive 3 pi. So now we begin to solve the 1D equation. Please find the Fourier series of fx in the interval. To find the Fourier series, we need to start with the n0, which 1 over 2l, integrate from negative l to l, integrate the fx function dx. So the fx function will give you same as the x. So now we need to integrate the x, which gives you x squared over 2. And we need to substitute the negative pi and pi in the x. The equation will be like this, and the result will be like this.
After that, we continue finding an. After n, we find an. So we start with this formula. It's given 1 per L, and then from negative L to L, and fx cos and pi x dx. Okay, and then we substitute fx to x. Okay, x cos, and then and pi x, and pi is cancelled. Okay, we get this. Okay, and then we integrate cos with the uv du. Okay, du. Okay, from here x is equal to 1 is dx. Okay, dx, and then integrate cos we get sine nx per n. Okay, and then we deal with that. We got 1 per x sine nx per n, negative integrate of sine nx and du. Okay, and then 1 per x, we integrate sine nx, we got cos, negative is positive, we get here. Okay, and n integration, we get down, and n squared, and pi negative pi. Okay, n squared, and then we got this, we substitute the pi from x become pi, and then we get this. Okay, and then sine and pi is equal to 0, so it's 0, we cancel out, this, and then we get this. Okay, and then we come from here is negative 1 per n, 1 square n, negative, and we get 0 from here, and it's equal to 0. Okay, and after that we continue with bn, and then this is formula for bn, so it's 1 per pi, so integration from negative pi fx sine and pi x per l dx. Alright, and then we substitute fx per x, and then we get this. We cancel out pi dx, still there. Okay, 1 per pi, and then we integrate this like sine and x dx, and then we integrate with the vdu. Okay, and then we get this from here. X is equal to 1 is dx, and sine is integrate sine, we get cos, negative cos nx per n, and then we got here negative x cos nx n, integrate negative cos nx n, and then negative is positive, so right here we got negative positive, and then we integrate cos, it becomes sine. Okay, nx, and then n, we put down n, we get n squared, 1 per pi. Okay, and from here is we cancel out x sine and pi, we get 0, equal to 0, sine and pi is 0, so 0, and then cos and pi, we get negative 1 power of n. Okay, we get this, and then come here, we put down, bring everything down. Okay, negative pi and negative pi, negative 1 or n square n we take out. Got this constant, we can bring out these two. Then pi, negative pi and pi, negative, negative, we get negative 2. And then we cancel out pi, and then 2 per n, negative 1, 2 per n. Yeah, answer. Okay. Okay, and then we get the a0, an, and bn is the final result, and then we sub with this formula that we given, and then we got this. Bn is equal to 2 and n is equal to 1. 2 is equal to negative, so 2 per 3, and we sub all in, we get this. Okay.
Okey, berdasarkan soalan 2 dalam chapter 4, given a function ft equal to t defined on the interval negatif 1 lebih kecil daripada t lebih kecil daripada 1. Soalan A, show ft is an even function. Formula untuk even function adalah f negatif t sama dengan ft, di mana ft sama dengan t, f negatif t sama dengan negatif t sama dengan t. Okay. Dapat dilihat jawapan akhir adalah sama antara f negatif t sama dengan ft. Ini menunjukkan ft merupakan even function. Seterusnya, soalan B. Hence to find the Fourier series for ft in intervals negatif 1 lebih kecil daripada t lebih kecil daripada 1. Formula Fourier series ialah ft sama dengan a kosong sum of an cos n pi t per l plus sum of bn sin n pi t per l. To find a 0, 1 per 2l integral L negatif L f t dt. Berdasarkan ft sama dengan t on the interval negatif 1 lebih kecil daripada t lebih besar daripada 1, dapat disimpulkan nilai L sama dengan 1. Nilai L digantikan dengan 1, di mana 1 per 2 kurungan 1 integral 1 negatif 1 t dt. Next, 1 per 2 integral 0 negatif 1 negatif t dt plus integral 1 0 t dt. 1 per 2 negatif 1 kuasa 2 per 2 0 negatif 1 plus t kuasa 2 per 2 1 kosong. Negatif 1 per 2 0 minus negatif 1 kuasa 2 per 2 tambah 1 per 2 minus 0. Last step is 1 per 2 bracket 1 per 2 plus 1 per 2 1 per 2 kurungan 1 A kosong sama dengan 1 per 2.
Seterusnya, untuk soalan 2B, step yang kedua ialah an sama dengan 1 per L integral negatif L ft cos n pi t per L dt. Kemudian masukkan nilai L sama dengan 1. An sama dengan 1 per 1 integral negatif 1 modulus t cos n pi t per 1 dt. Dan kita akan dapat 1 bracket integral negatif 1 kosong negatif t cos n pi t tambah integral kosong 1 t cos n pi t. Kemudian u sama dengan negatif t, bezakan du per dt sama dengan negatif 1. U sama dengan negatif dt. dv sama dengan integral cos n pi t, v sama dengan sin n pi t per n pi. Untuk u sama dengan t, du per dt kita dapat 1 du sama dengan dt. dv sama dengan cos n pi t, v sama dengan integral cos n pi t dan jawapan akhir adalah sin n pi t per n pi. Masukkan nilai ke dalam uv, tolak integral v du negatif t. Negatif t, sin n pi t per n pi tolak sin integral sin n pi t per n pi tolak dt. Masukkan nilai ke dalam persamaan uv, tolak integral v du bagi positif t, kemudian jawapan akhir bagi n ialah sama dengan negatif 4 per n kuasa 2 pi kuasa 2. Kemudian cari nilai bn. Bn sama dengan 1 per L integral negatif L fx sin n pi per n pi x per L dx. Sama dengan, kemudian masukkan 1 ke L sama dengan 1 per 1 integral negatif 1 modulus t sin n pi t dt. Jawapan akhir bagi bn ialah kosong. The Fourier series for ft in the interval lebih besar daripada negatif 1 dan kurang daripada 1 ialah ft sama dengan 1 per 2, sigma infinity n sama dengan kosong, negatif 4 kuasa n tambah 1 per n pi kuasa 2 cos n pi t.
Then we continue with the question number 3. Find the furthest transform of the function of t in the figure 1. Let's see the figure 1. We get the figure 1 and this, so we need to find the ft. And here we can see that we got the function is not only 1. So we have to find what is that. From negative t to t, we notice about that is which is the ft is equal to 1. So when the ft equals to 1, the x is negative t until t. So we write with it. Sorry, which is this is t. So t negative t is t. The others is 0. So we also write that when the ft is 0, the x will be less than negative t and the x will be more than t. But because which is they left the two one, so we don't write like this. We just write the otherwise. That will be easier. So otherwise will be 0. That's all. Thank you.